Lesson 8.6, Day 1, Radical Expressions and Rational Exponents. Essential question, how do I simplify radical expressions? Please write that down. Who uses this? Guitar makers use radical expressions to ensure that the strings produce the correct notes. You are probably familiar with finding the square and square root of a number. These two operations are inverses of each other. Similarly, there are roots that correspond to larger powers. 5 and -5 are square roots of 25 because 5 squared is 25 and -5 squared is 25. 2 is the cube root of 8 because 2 to the third is 8. 2 and -2 are fourth roots of 16 because 2 to the fourth is 16 and -2 to the fourth is 16. So in general, A is the nth root of B if A to the n power equals B. So the nth root of a real number A can be written as the radical expression right here, where n is the index of the radical and A is the radicand. When a number has more than one root, the radical sign indicates only the principal or positive root. So this table down below here and this reading math section at the bottom says when a radical sign shows no index, it represents a square root. So that's a square root. You will never see a 2 over here. When there's no index, square root. So if we have an odd index, that means we have one real root right here. Odd index, the 3, one real root. Even index and a positive radicand, 2 real roots. Even index and a negative radicand, 0 real roots. And when we have a radicand of 0, 1 root of 0. So if I said x squared equals 16, -16, we take the square root of both sides, we'd say x is equal to plus or minus 4i. In this case, we have an even index, which is 2, and a negative radicand. That gives us 0 real roots, and they're just imaginary roots. Example 1. Find all the real roots. Right, it's asking for the 6th roots of 64. Well, 6 is an even number, so therefore, when we look back, even index, positive radicand, 2 real roots. So we know that we're basically asking what number to the 6th power is equal to 64. Well, I know that 2 to the 6 equals 64. And I also know that -2 to the 6 equals 64. So the real roots to A are 2 and -2. A cube root of -216 basically is saying what number to the 3rd power is -216. When we have an odd index, let's go back, odd index, we're going to have 1 real root. And so we know that -6 to the 3rd power is -216. So the real root here is -6. And that's what we're finding. We're finding all the real roots to a -2, in this example, -6. The 4th root of -1024. Well, even index, negative radicand, basically is asking what number to the 4th power is -1024. That can never happen. Any number raised to the fourth power will end up being a positive. And they're saying we're having a negative, so that's no real roots. Let's see, I don't think there's anything else there. Example 2, we're going to do in class. And now, the properties of nth roots for a greater than 0 and b greater than 0. We're talking about the product property of roots and the quotient property of roots. So that's basically saying that the nth root of a product is equal to the product of the nth roots. Just like this. The cubed root of 16, we could break that up into the cubed root of 8 times the cubed root of 2. 8 times 2 is 16. We can multiply those because they are under a radical sign that they both have the same index or same root. The quotient property of roots says that the nth root of a quotient is equal to the quotient of the nth roots. So right here, I have the square root of 25 over 16. We can break that up into two separate radicals. We'd want to do that because the square root of 25 is 5 and the square root of 16 is 4. Makes it nice and easy. So when we have a fraction underneath a radical sign with one index, we can separate them into two separate radical signs. When an expression contains a radical in the denominator, you must rationalize the denominator. To do so, you rewrite the expression so that the denominator contains no radicals. And we will talk about that when we get to that. So example 3, simplify the expression, assume that all variables are positive. All right, so now here is how we're going to break this apart. We have to separate this into separate radicals. So I'm trying to think of, I want to break this up because I want to think of what number to the fourth power gives me 81. That's the first thing I have to do because I have to change that to a number to the fourth power. Well, I know that 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3. So I can break that up into 3 to the fourth root. And now x to the 12th, we're going to break that up into, because we're dealing with an index of 4, we're going to start with x to the fourth, and we're trying to see how many of these I need. Well, I know that x to the fourth times x to the fourth is x to the 8th, so I think I need one more x to the fourth to get me x to the 12th. Because when we multiply bases that are the same, which are the x's, we add the exponents. So now, because the exponent and the index are the same, they cancel and the number comes out of the radical. Same thing here, the variable comes out. Variable comes out, and the variable comes out. So that's going to be 3x to the third. That is how we simplify the fourth root of 81x to the 12th. Example 4 and 5 we're going to do in class. Example 6 I'm going to do now. So now we have, it says simplify the expression, and we have a fraction or a quotient under a radical sign with an index of 4. So the first thing we're going to do is we can break that up that and like that. All right. Well, I'm looking in the top, and I can break that numerator up. I'm looking again at my index. It's a 4, so I know my first one has to be x to the fourth root because I want them to cancel. So, oh, I have another one because x to the fourth times x to the fourth is x to the 8th. And on the bottom, we still just have that. All right. So now, look, we have that cancels that cancels that That x comes out. That x comes out. So I have x squared over the fourth root of 3. But remember, we cannot leave a radical in the denominator. So I know that my index here is a 4. That means I need 4 of these multiplied together to get rid of the radical. If this was a 5, I need 5 of them. This is considered 1, 2, 3, 4. So I multiply the bottom and the top. We can do that whenever we multiply the bottom, as long as we multiply the top by the same thing. That's like multiplying everything by 1. Okay, so we have on the top, we have an x squared. 3 times 3 times 3 is 27. And on the bottom, I have, how many 3's do I have? Well, I have 1, 2, 3, 4. That's like 3 to the 4th. We're going to get so good at that we're going to recognize that what's going to happen is the purpose of multiplying by that many is so that they can cancel and then the 3 comes out. So what we are left with, I'm going to draw an arrow so that we know to come up here. We have an x squared, 27, fourth root over 3, x squared. And that's it. That's how we rationalize the denominator. Example 7, we're going to do in class. And video question. Simplify each expression. Assume all variables are positive. And simplify again. Another one. Assume all variables are positive. Please do those video questions in your notes.